multiply and divide rational expressions, the same thing holds true. You do not need to have a common denominator. A lot of students get really confused between multiplying and dividing and addition and subtraction, where you do need a common denominator. You'll still get the same answer if you have a common denominator, but you are wasting precious seconds, in some cases minutes even, trying to find one. So it's best to just not try to find a common denominator when you are adding or when you are multiplying or dividing. And just like what we did in simplifying, we need to be able to factor everything first. And you've been factoring or you've been multiplying and dividing fractions since you were in elementary school. So there's no different process here for rational expressions. Multiplying fractions, that's no problem. Top times the top and the bottom times the bottom. So once you've factored everything, you're going to multiply the top or numerator times the top and the bottom times the bottom. And then you're going to simplify just like we did in the previous lesson. Now there are two kinds of multiplying problems that you're going to see, one with monomials and one with polynomials. With monomials, I'm going to show you two different ways. One of the ways is really showing you how this process and the process with simplification that we learned in our last lesson are related, but I would say the second way should be your preferred method. The first way, and you don't have to write this method down, but the first way is when we are factoring everything, that includes prime factorization. So that means that 27, if we were to do a factor tree for it, we'd get 3 times 3 times 3. X squared is x times x. Y to the fourth is y times y times y times y. Then 16, if we did prime factorization or a factor tree for it, we would have 2 4 times, 1 y, and 3 z's. 8, we would have 2 times 2 times 2, 1 z. And then in the bottom, we would have 9, which is 3 times 3, 1x, and 3 y's. Technically speaking, this would be representative of factoring everything. Let's go ahead and take a look now at our next step, which would be to go ahead and multiply the top times the top and the bottom times the bottom. So when we multiply the top times the top and the bottom times the bottom, what we're really doing is creating one massive fraction. So we're multiplying the top and the top and the bottom and the bottom. So it's creating one massive fraction. And then we simplify. Since we've already factored everything, we can go ahead and circle every factor. Now, this is kind of overkill, but I'm just trying to make the connection between what we're doing today and what we did in our last lesson. Lots of factors to circle. A lot more than there would be for polynomials. And we are canceling identical factors. So I have a 3 on top here with a 3 on the bottom, a 3 on the top with a 3 on the bottom, an x on the top with an x on the bottom, a y on the top with a y on the bottom, 3 y's on top, 3 y's on bottom, 3 2's on top with 3 2's on the bottom, and 1 z on top with 1 z on the bottom. And then we're going to write what's left. We have 1 3 left on top, And then we also have 1x. On the bottom, we have a 2 and 2 z's. So there's our simplified answer. I don't expect for you guys to do it with this method every single time. We've created rules which act as shortcuts in this process when they're monomials. The first rule is the ability to multiply and then simplify fractions. So we can do, this is going to be considered factored because there are no more addition and subtraction signs. Then we can go out and multiply the 27 and the 8. So 27 times 8 gives me 216. And then x squared is the only x term up there. Y to the 4th is the only y term. And z is the only z term. Then on the bottom we have 16 times 9, which is 144. Y to the 1st and y to the 3rd means that there are 4 total y's down here. We add exponents when we multiply their bases. Z to the 3rd and an x. We're still going to circle our factors. But this time, we're not just looking for identical factors. We're looking for what I can do with similar factors. So 216 over 144. That is a fraction that I can simplify, and I'm going to use my calculator for that. 216 divided by 144. That's how we enter a fraction into our calculator. And to change it into a reduced fraction, we press Math and enter twice. So we get 3 over 2. Then I have an x term on top, or an x factor on top, an x factor on the bottom. So x squared and x. There's a rule, that's our second shortcut for exponents. It says when you're dividing their bases, the exponents get subtracted. 2 minus 1 is 1. And since the 2 was bigger, x to the 1st goes to the top. 4 minus 4 is 0. So there's no more y's. And z cubed, the bigger number is 3. So 3 minus 1 is 2. And since the z cubed was bigger, z squared is going to go to the bottom. Either way you work it out, you still get the same answer. This one just has some shortcuts in there. Take a look at number 2. In number 2, we have to factor first. So we have a times c, which is negative 21. Factors include 1 and 21, 3 and 7, and we want it to multiply to be a negative and add to be a negative. So there are our signs. I know I'm writing kind of slow here, or kind of small here, so I'm going to zoom in just a little bit here. So you can see the factorization. We have x squared. Here, I need to move that box down just a smidge so I have room to take something out on the top. X squared and negative 21. Then our negative 7x and our 3x. I can take an x out, a 3, an x, and a negative 7. So this top will reduce down to be x minus 7 and x plus 3. Now for the denominator, a times c is 8, 1 and 8, 2 and 4. We want to use 2 negatives. So x squared and 8, then negative 2x and negative 4x. we can take out an x at the top, a -4 on the bottom, an x, and a -2. So x minus 4 and x minus 2. There's our first fraction. Our second fraction, the numerator, has already been simplified or factored to x minus 4, but the denominator needs to be factored. So we have a times c is -35, 1 and 35, 5 and 7. We want to make our larger factor negative. So x squared and -35, then 5x and -7x. I could take an x out, a -7, an x, and a 5. So x plus 5 and x minus 7. Now we're going to multiply the top times the top and the bottom times the bottom. That means that this is going to become one giant fraction like what we saw in our last lesson. And it's time to simplify. It's already factored, so we're going to circle our factors. And find our excluded values. We didn't have to find excluded values in the first one because there were multiple variables. But setting x minus 4 equal to 0, x minus 2 equal to 0, x plus 5 equal to 0, and x minus 7 equal to 0. So x cannot be 4, x cannot be 2, x cannot be -5, and x cannot be 7. So there are 4 different excluded values because there were 4 factors that had an x in the denominator. It's time for the most satisfying part. We're going to cancel out identical factors. So I have an x minus 7 on top, an x minus 7 on the bottom. Here's an x minus 4 on top, and an x minus 4 on the bottom. All that's left is x plus 3 on top, and on the bottom, x minus 2 and x plus 5. I gotta move it up just a smidge here, I think, so it's not crammed on the bottom. So here are our excluded values, and here's our simplified expression. There's no need to multiply this out because all that does is open yourself up for potentially more silly or careless errors.